Hello and welcome to edupediaworld.com, your favorite portal for online education. In the last two sessions, we had been seeing mode. We'll continue the same and we'll wind up this topic today. We'll take up a few special cases of mode. But before that, let's review what we did in the previous two sessions. We had seen the calculation of mode by method of inspection, when the data was regular, and the method of grouping when the data was irregular. Okay, and this was the case for both the grouped and ungrouped frequency distribution tables. The only difference being that when it was grouped, we did not get the mode directly but had to use the interpolation formula from the model class, and the formula to calculate mode was given by lower value of the model class plus delta 1 by delta 1 plus delta 2 multiplied by the width h, where delta 1 was equal to the frequency of the model class minus the frequency before the model class, and delta 2 was frequency of the model class minus the frequency after the model class. Alright, this session we'll take up some special cases. Now when you're calculating mode, and if the data is given, say you have a variable x and the frequency f, say starting from x1, x2 and so on to f1, f2 and so on. Now suppose if the model class or the mode, the highest frequency, falls in the first or in the last case, okay, if the highest frequency or the model class after the model class, either by by the method of inspection or by method of grouping, if it falls in the first or the last class, that is the first or the last frequency the highest, or if suppose there are more than one, say for example there are two values in between, say f2 and f3, both of these have the highest frequency. In all of these cases, the mode is said to be ill-defined. Okay, the mode is said to be ill-defined, and whenever the mode is ill-defined, we cannot use the interpolation formula. Okay, the general formula. What we will have to do is we will have to calculate the mode using the relationship between mean, median and mode. Of course we have not seen the relationship as of now, but let me just give you, and this the formula which we have based on the relationship, and this is an empirical formula. Okay, you don't get the exact value of mode, of course, because it's ill-defined. You get a value which is very close to, or in this case which fulfills the relationship, and this empirical formula is the relation based on what has been seen most often, and it's given by the mode equals 3 times median minus 2 times mean. Okay, so this is the empirical formula which you will be using when the mode is ill-defined. And when the mode is ill-defined, let me just repeat, whenever you have more than one highest frequency or more than one model class, either in case of method of inspection or method of grouping, whether for grouped or ungrouped data, or you have more than you have the highest frequency falling in the first or the last class. Okay, so let me write that here. Highest frequency in the first and the last class. Okay, or if you have more than one highest frequency. Okay, so let's take a numerical question based on this, and then we will take up the next special case after we complete this one. Alright, so this is a question where you have the it's ungrouped. You have the x, the variables, and their frequencies given here. First and foremost, we will have to check if they are regular or not. So we see that it is small, gradually increasing to 15, then 20, but then there is a sudden rise from 20 to 100, a sudden jump, okay, which is unusual. And then when we see that it recedes back very gradually from 100 to 98, 95, 90, 75, 50, 30. So it's coming down gradually, whereas it jumped all of a sudden. So of course this is a case where we can say that it is not regular. We will have to use the table, the grouping table. Okay, so you're already familiar with it, so let's do it. We need to draw 2, 3, 6 additional tables, additional columns. In the first, we know by now that we have to take 2 at a time, taking the sum of 2 at a time. So it is the first one, 8 plus 15, and the next onwards we will have to just take 2 at a time. You can simply drag and drop it down. In the next table we will have to again take 2 at a time, but summing from the second one onwards. So here we will take the sum of these two, okay, and then dragging it down to up to this. We won't be taking the last one because it's left alone. Now onwards we will take 3 at a time. So sum of 3 at a time will be 8 plus 15 plus 20, and then drag it down to the columns below it. Well, we are left again with 1. Again we will take the sum of 3, but from the second one onwards. So here this will be the sum of 15 plus 20 plus 100, and then drag it down to the next level, next 3, and then next 3. Lastly, we will leave 2 from the top and take 3 at a time. So here it will be 20 plus 100 plus 98. Okay, and then yeah, that's it. We can't take the next 2 because we are left only with 2 values, not 3. And then finally we will have to mark them. We'll have to mark the maximums of all these maximums. So here the maximum is 100. Next we see the maximum falls here, 193. Next it's 198 in this column, 193, 198, then here it's 293, here it is 283, and here it's 260. So we have these maximums. Now let's count the maximum. No maximum has occurred in the first row, so it's 0. The second row again, there's no maximum, 0. Third row, if we see again, there are no maximums in the third row. Fourth row we have 1, 2, 3. There are 3 maximums in the fourth row. Fifth row there are 1, 2, 3, 4. There are 4 maximums in the fifth row. Next again we have 1, 2, 3, 4. Oh, fine. So again we have 4 maximum here. This is what I was telling you when I said that you have two values having the maximum frequency. The next here we have 1, 2, only 2. This has only 1, and finally the last one is 0. There's one more which is 0. Okay, so we see that there are 2 which are maximum. So these are the 2, and then we now see that it corresponds to 14 and 15. So can we call both of these as mode? No, we will have to use the empirical formula, and to get the value of mode through the empirical formula, we will have to find the mean as well as the median. So let's do that. Mean and median. We need some space here. So I've just clubbed them. Let me do that here. So for mean, of course, we need I'm doing it quickly so that you already know, and you can use a different method if you're doing it on using paper and pencil. But since I'm doing it on Excel, I can comfortably use the direct method because it's hassle free in terms of calculation. So to calculate mean, of course, I need the x into f value. So my x is this multiplied by the f, which is this one. Okay, I can drag it down now. Fine. I need the sum of the frequency. Sum of the frequency happens to be just sum all these values up to 30. Yeah, 581 is the sum of the frequencies, and then we need to sum the product of x and f. The sum is 8767. Okay, and then mean, let me calculate the mean here. Mean will be equal to the sum of x into f divided by the sum of f, and that happens to be 15, or I think there should be some, yeah, it's 15.089. We can round it off to 15.09. Let me round it to the second decimal place here. Up to 2 decimal place is fine. So 15.09 is my mean. Next, to calculate the median, let me do it here. I need to find the cumulative frequency. The cumulative frequency in the first one is 8. The second one would be the sum of 8 and the next frequency, which is 15, and so on. The last one should come as 5. Oh, sorry, I think not get summed. Oh no, the formula is not complete, so it's 15 plus 8, yeah, 23. The next should be 23 plus 20, 43. Yeah, it's working now. So on, and 581. So these are my cumulative frequency, and since it is your n is odd, we need to let's do what is n by 2. N by so of course it is odd, so you need just one value, and that is n plus 1 by 2. Sorry, n plus 1 by 2. and then plus 1 by 2 you can calculate here. There is n plus 1 by 2 equals 291. I need the 291st data from this. So 291st observation, where's my cumulative frequency? It's here, yeah. So 291st, now we see up to 8, the next one is up to 23, up to 43, to 143, up to 241. Since I need 291th data, it falls in this class, that is the one corresponding to 366, and that happens to be 15. So my median for this is 15. Mean is, we have got the mean here. Let me write median here. Median is 15 based on the calculation which we, and finally now we are ready to calculate mode. Let me do that here. Mode, as we know, the empirical formula is given by 3 median minus 2 mean. So this will be equal to 3 times median minus 2 times mean. Exactly. So now the mode is 14.8. okay, quite lengthy. In fact, you got to revise your mean and median as well in this case. So this is the way to go about, in case if the mode happens to be ill-defined, right? Well, so that was the thing. Let's practice a question now based on the same concept. Here we have, and this time we have class intervals. Alright, so class intervals with frequency given here. Pause me for a while as usual and try to do it yourself. Alright, so first we'll see whether it's regular or irregular. 420, here itself we see that the value first decreases, then increases, then decreases, again, decreases down, and finally, so here itself we see that it's not increasing and decreasing gradually, but first it's decreasing slightly and then again increasing rapidly, then to some again increasing further and then decreasing down gradually. So we see very clearly that the data is irregular. So we will have to do the method of grouping. So let's take 2 at a time first. We'll have the sum of these two, 4 plus 2. Drag it down. Next we will take 2 at a time from the second one. Okay, then we will take 3 at a time from the top. And then drop it down to the rest of the cells. 3 at a time from the second one. So it will be the sum of 2 plus 18 plus 22, and then bring it down to the next cells. We can only extend it to this because the rest we are left only with 2, and then leaving 2 from the top, taking 3 at a time and summing. It will be 18 plus 22 plus 21. Okay, and then further down, I think we can again extend it only to 1 level, and then let's find the maximum in each of these cases. Here 22 is the maximum. Let's use the color we are using. Next here, well, 2 maximums here, both 40s. Here it is 43 here 62, and here it's 50 and 61. Okay, now we need to count the maximum. Here it is 0, next one also is 0, next we see there are 1 and 2, so 2, next we see 1, 2, 3, 4, 5, well 5 here, next we see 1, 2, 3, 4, 5, oh well again 5 again, next we see is 1, 2, 3, only 3, next is 1, only 1, and here onwards we have 0 and 0, all these cells. So again we see that there are two maximums here, two 5s. Okay, so both of these happens to be 5. Of course we can't pick both the classes corresponding to 120 as the model class, because we need to have only one, and so clearly this is a case of ill-defined mode. We will have to use the interpolation formula, we'll have to use the empirical formula, and we will have to find the mean and median. Let's do that quickly. You need x multiplied by f to find the mean, and that will be, well, here again we don't have x also, we'll have to first get the midpoint of all these classes x. So x here it's from 90 to 100, so of course the midpoint is going to be 95, and the next one will be 105, 115, 125, 135, 145, 155, 165, and finally 175. So these are my x values. Then I need the frequencies which are here, so I can now calculate my x into f. So x is here multiplied by f, which is in this cell, and then I can drag it down to all the remaining cells. Yeah, so then sum the frequency. Let me find the sum of the frequency from 4 down to 1, and we see the sum is 100. And also we need to find the sum of x multiplied by f. X multiplied by f is given by 13220. Okay, so let's do the mean here. Mean is the ratio of x, sum of x into f divided by sum of f, and that happens to be 132.2. Next we need to find the median. We need to find the cumulative frequency. Cumulative frequency for the first one is 4. Second one would be the sum of the first plus the second frequency. Third will be the sum of first, second, and the third frequency, and so on. When I drag it down, of course the last one should be equal to 100. Yeah, it is. Next, since it is 100, we need two values. One is n by 2, of course n by 2 is 50, and n by 2 plus 1, which is 51. So I need the 50th and 51st data. 50th data happens to be here, right, this one, so 130 to 140. So this is my median class. Now median class, I need to calculate the median from this. So median using the interpolation formula for median, and what is that? It's the lower value of the median class, which is 130, plus n by 2. N by 2 is 50 in our case, 50. Of course some of the calculations we can do manually, so 50 minus cumulative frequency before the median class. This is our median class, and the cumulative frequency before the median class is 46. uh, 46 divided by the frequency of the median class, which is 21, and the whole thing multiplied by the value of h, which is the width of the median class, which is 10. 140 minus 130 is 10. Okay, so my median happens to be 131.90476. Okay, so I have got my median, I've got my mean. Now I need to calculate the mode. Mode is given by 3 times median, yeah, 3 multiplied by the median value, and then minus 2 times the mean value, yeah, and so the median happens to be 131.31. Sorry, the mode. So this is our mode. Okay, I've not highlighted everything. I've not you know been very specific to the calculations of mean and median, because we have already done this previously and you know how to do it, so I was just focusing on this. Anyways, so this is the calculation of our median when the mode is, sorry, calculation of mode when the mode is ill-defined. Okay, fine. So now that was one case, and another case is well, let's take a problem and then we will see what is the hurdle we are facing in this. We have already seen two types. So here again, let's first check whether the data is regular or not. Okay, we see that it's starting from 7 going up to 15. Okay, fine. Then going up to 18, good again. Going to 30, fine, increasing, then coming down to 31, but then suddenly dropping down to 4. You see that it's starting at 7, gradually increasing by a gap of some small numbers up to 31 in 5 steps, but then it's coming down to even below the first one in 1 step. So definitely this is not regular, and we will have to use the grouping table. Okay, so here the first one we will take 2 at a time. Okay, and sum them up. Next, drag it down. Next, I'll have to take the sum from here onwards. Yeah, to this. Then we will take 3 at a time from top. Okay, again 3, drop it down to the next level. We can't drop it further because we're just left with 2. Next, leaving the first one, 3 at a time, and that will be equal to the sum of 15 plus 18 plus 30. Okay, next again to one more level. Yeah, and finally the last one, leaving 2 from the top, taking 3 at a time. This will be equal to 18 plus 30 plus 31. Okay, right, so now we need to find the maximums in all of these cases. Here 31 is the maximum, here 48 is the maximum, 61, 65, 63, 79. Okay, so these are the maximums, and then let's count the maximum in each of these cases. In the first case there is no maximum. Second case we see just 1 here, right, falling in the path, so it's 1. Third case it's 1, 2, 3, so 3 here. Fourth case 1, 2, 3, 4, 5, well 5. Next one we have 1, 2, 3, 4, only 4. Here we have 1, well only 1, and 0 from here onwards. Yeah, so here we see that of course it's not ill-defined, it's very close to, in fact it is of the first category, the first type. So we can use the interpolation formula. Let's see if we are getting or not. So here 5 happens to be the maximum, and then the median class we see is from 30, sorry, model class is from 30 to 40. Okay, lower value of the model class, let me write all of that. Model class, lower value of the model class is 30. Width of the model class, that is h, here is 10. 40 minus 30. Then we have the frequency of the model class. Frequency of the model class is again 30. Now you see that the maximum frequency was here. Till now, you know, in all the problems which we had seen, even after method of grouping, we saw that you must be feeling that it's unnecessary to draw the method of these tables, but then here you see that the maximum frequency is here for class 40 to 50, but our frequency of the model class is 1 less than the maximum, it's 30. So frequency of the model class is 30. Frequency before the model class happens to be 18, and frequency after the model class happens to be 31. Okay, now let's calculate the values of delta d1, and as we write it, d1 equals, let me just extend these two cells. Yeah, so d1 equals frequency of the model class minus frequency before the model class, and d2, sorry, equals frequency of the model class minus the frequency after the model class. And we see here that one of the deltas is negative. Yeah, so this is the unusual thing here. Now when it happens, when a number which is the maximum does not falls into the model class. Okay, so we see the unusual thing which in this problem is that one of the deltas has become negative. So whenever you have any of the delta values other than negative, we can't use the regular formula which we have. Okay, so in this case we have another formula. Let me give you the formula now. Let me write, this was the first formula or the first case, this was the second formula or the second case, and now the third one. The third formula or the third case here will be when let me write the formula first. Your mode in this case will be lower value of the model class, okay, plus, now instead of delta 1 and delta 2, I'll be using f2 divided by f1 plus f2. This is an approximation of this previous formula. This is an approximation of this formula here, and this of course will be multiplied by h. So here again we know what is f1 and f2. Okay, this is before is f1 and after is f2. So lower value of the model class plus frequency of the frequency before the model class f2, sorry, frequency after the model class divided by the sum of the frequencies before and after the model class multiplied by the width of the model class. And when do we use this formula? We use this formula when any of the delta values, any of deltas, say delta 1 or delta 2, is negative. Okay, so whenever the delta values are negative, the regular formula is not applicable. We use the approximation formula which is given by this. Okay, let me just mark this formula. Alright, so now we are ready to do the thing, calculate the mode. Let me do that here. Mode, lower value of the model class, which is 30, plus frequency after the model class. Now frequency after the model class is 31, so let me put that here, 31 divided by sum of the frequencies before and after, so it will be before is 18 plus after is 31, yeah, and the whole thing multiplied by the width, which is 10. Well, so this is our mode for this problem. Okay, let me give a different color here. Alright, so this was the second special case which we wanted to see today. With that, we have completed the topic of mode. Although these are rare instances, but we may have, these cases coming often, so you need to know this. With that, we have completed the treatment of mode. In the next session, we will take up a new topic. Till then, bye bye.